the things we want.
Yeah.
And we can do the same thing with the joining region. For clonotype diversity, it's a little bit different because here, what we're looking at are those, looks like there's just 100% diversity. None of these populations have the same clonotypes. But otherwise, there'd be a little slice here that would be the consensus clonotypes.
Yeah.
But we should see something similar if we look at a matrix of consensus versus non. So they're all just unique. But
Well, no, wait, this is interesting because we think that naive, the plasma cells should be somehow related to the precursors. So, in other words, some cell starts out as a naive cell and then it goes to a memory, or maybe not, but anyway, the plasma cell should be a subset, at least some relationship to what the naive repertoire is. Possibly.
Okay.
So is there a way to, you say
Well,
overlap?
I think the only way you could potentially start to look at that would be looking at individual genes. So if we went to one of these, I'm not sure exactly how I would tease that apart here, but you could say that, let's see. So the entropy between the IgHG positive B cells and the naive B cells is very low. So, meaning that there's probably more of the joining region genes that are shared by these two populations relative to like memory B cells and IgHG positive B cells. I'd probably make a bad comparison there because, here we go, so comparing between naive B cells, memory B cells, and plasma B cells, the entropy is less between naive B cell and memory B cell than it is between naive B cell and plasma cell.
Is, this entropy thing, what about, maybe this is the same thing, but the sequence, like variable region or whatever usage, between naive and, in other words, if the B cell starts out as a naive B cell, it has a V region for its Kaplan-Meier chain, and supposedly some of those, they don't change the V region, they just change, they undergo semantic identification, maybe class switch. In any event, the V region stays there. Is there a way to sort of look at the V region usage at the naive versus the V region use at the memory stage? Plasmablast stage, for example, or memory. They should.
Well, we didn't identify plasmablasts unless that's 38 positive or IgHG positive, but
Or memory. The
but
V
we
region
can
should.
look at the V region, right? Variable IRAC.
Right. The V
Here we're
region
looking
should.
at a comparison of naive to the rest of the subpopulation.
Okay, yeah. The V region should be represented later in the B cell's life, or some B cell's life, but it'd be interesting to see how it expands or contracts based on the environment.
Okay. Well, and maybe the environmental part of that would be looking at those two patients. I'm not sure.
Or even
but-
within a patient, they've got different environments inside of them. One's a sick one, as you know, 165 has more disease than 166.
Right.
So the 165, promotes more B. I don't know. I'm not sure exactly how to say it, but they have more B cells that make it to the end. We don't know. There's how things are. They talk about negative selection. They mean, in any event, they start out and then they get trimmed back based on what they bind to. And it'd be interesting to see if there's a way to look at that trimming back, and especially if 165 doesn't trim back with many B regions or many clonotypes. In other words, the 166. But what I'm really thinking of is this entropy thing. You're comparing based on some entropy, and what we really want is the repertoire or something like that, or the sequence. And
So,
which
we talked a little bit about the sequence information, and we can't give you back the sequence information. That's further off in terms of what we could potentially do.
Or how about a V region diversity in early stage B cells versus the last stage, like the naive versus the plasmablast? I would guess that the diversity of the V region, there'd be some V regions that are
You're saying the variable region?
Right.
Okay. So what I'm seeing in the variable region, comparing just the memory, naive, and B cells, they don't look like they change much, maybe with the exception of, no, even, so if I look at plasma cells,
Yeah.
B versus naive look about the same. And if I look at naive cells, memory versus plasma look about the same. And if I look at memory cells, naive and B, well, maybe in memory, there's a slightly greater entropy between plasma and memory than between naive and memory. But
Is
for whatever
entropy,
reason,
now is entropy the best?
entropy isn't changing much.
Is there a way to look at it other than entropy? You know, that's to me, I don't know what that means exactly. I got this, biological, concept of entropy. But is that the same as sequence homology?
No, it's nothing to do with the sequence except for the gene that was called by a given sequence. Because all we have is the information of, a given gene
Yeah.
or a set of cells.
I mean, what do you mean by entropy in this case?
Yeah, so I don't know, I would be hard pressed to define it exactly, but I understand it's a comparison of the differences, different genes between two populations. I know it's commonly used in population comparison. The two terms used for it that I've seen are Benson-Shannon divergence index, or entropy, or information radius. It's the same thing.
I don't choose the trees in ecology.
Right.
Like if you're looking at how cells
I see, yeah.
population.
Probably, yeah, he's saying like tree. So the number, I don't know, this is derived, which is a good thing to do, a tree thing. This is derived from that, and this splits into that and that, That's sort of I had to think about it. But
Yeah.
may not be exactly what we want. Why is that? Because the differences may be subtle, and that's what most people think. And there's not, the autoimmune person isn't like from Mars. They're really just like almost normal, and the spectrum of antibody use is still almost normal. Just a few bad ones in there, and it's been a long decades of work trying to figure out how the bad ones get there and what exactly is a bad one. But they're not you look at it and it doesn't jump out at you.
Okay, well, if there were other statistics that you wanted to look at for the gene usage in variable, or any of these different pieces of meta information, I'm sure that's not a leap to implement,
Yeah.
but we would just need to know what statistics you guys want to look at in terms of, again, this is comparing the variable genes being used in all 5 of these subpopulations to one another.
I mean, what the statistic would be interesting is a pie chart of the actual variable genes, and like start with naive, you'd see a pie chart. I mean, maybe there's 50 different B regions used. Let's say in just the heavy chain, there's 50 there, and then you'd see in the plasmablast, how many there are there, and especially they should line up. Some of the ones that were there in naive should also be there in the memory, but some are in plasmablast, but some shouldn't. So a pie chart of the B regions in the first stage and the last stage, is there a way to do that?
Or I say, Ian, have you heard of a circus plot?
Or
Yes.
right.
Yeah.
Or a circus plot, yeah.
Also called a chord plot.
Mm-hmm.
Right.
Yeah. So
That's what I was-
perhaps that.
Yeah, I'm writing this down.
Yeah.
And this is something we definitely considered. There's a number of different applications where a Circos plot would come in handy,
Yeah.
including in VDJ.
Yeah.
Currently, just thinking about what we have, and so that's on the list. But something we do have are these stacked bar charts, and I heard you asking kind of which variable genes
Oh,
are
right.
in which populations.
Yeah.
Oh, yeah, that's it.
Yeah,
I guess you
Is
can
there
see
even
it.
like a way to sort of pull out, which, if you're looking at, the different populations, is it sort of overrepresented with a particular V gene, without having to like kind of eye it and say, oh, this looks overrepresented in this population and not so much in the other ones.
Yeah, like I think Bing is asking for maybe the number, and then we could plug it into some analysis, like just do analysis of the ratio of this versus that, or and see, we can see here there's a purple. What is the purple memory down there? The memory is just down at the first half of this, but not in the last. Maybe the some. But then it looks like then on top of that, naive is so much, and there's a lot of representation of the IgH positive. But we're talking about naive at the bottom. There's a purple. I get no pink, and then plasma is what, the green. So how many? What's the ratio of green CD38? Is that plasma? Is there any more? Oh no. What's the ratio of plasma? Plasma is that. The
We could
plasma.
make gray, or whatever color you want, really. If you're only interested in, what was it,
I
plasma
can't
and
see.
memory?
Yeah, plasma to naive, let's say. Can you just, how would you show that? Like just plasma naive. Maybe, you turn those off. Is that what you do? So plasma to, how about naive to plasma or plasma to naive? Like, make it naive, give a nice color. So naive is green, but yeah, that's good. So naive, that kind of shows it. You see naive is there, and then that particular green region is represented differentially by the time we get to the plasma cell. And I can see some over here that doesn't seem to persist. And others, are strong. Anyway, some persist more. And to do this in the two subjects, 165 versus 166, that would really be something. If we could do this.
There's no way currently, and it's difficult, I can't exactly think of how we would do it, to show